Okay, Chemistry 1401, this is homework 4, question 25. It says zinc and sodium metal each react with sulfuric acid according to the following equations that we have shown here. So they both react with sulfuric acid to produce zinc sulfate and sodium sulfate, hydrogen gas as well. Then it goes on and says if you have a 25.40 gram mixture of zinc and sodium, and you react it with a stoichiometric amount of sulfuric acid, so that's all the just exactly the amount of sulfuric acid you would need to consume both of those metals. The reaction mixture is then reacted with 164 milliliters of 2.96 molar barium chloride to produce the maximum amount of barium sulfate. Determine the percent sodium by mass in the original mixture. So let's write down what happens when we combine our zinc sulfate and our sodium sulfate with barium chloride. So our zinc sulfate, which is aqueous, is going to combine with barium chloride, which is a soluble compound, to give us zinc chloride, which is soluble, plus barium sulfate, which is a solid. And you see the stoichiometric ratio of barium sulfate to barium chloride is 1 to 1, right? We have a stoichiometric coefficient here of 1, which is assumed, and 1, which is assumed there. And that's going to be important in just a second. Then if we write out the reaction between our sodium sulfate, which is aqueous, with our barium chloride, we end up producing 2 moles of sodium chloride. So here 2 moles of NaCl, which is aqueous, of course, plus barium sulfate, which is a solid. Okay, so we can see again that the ratio, the stoichiometric ratio of barium sulfate to barium chloride is 1 to 1. All right, so since we have created our barium sulfate, all of the barium sulfate from our barium chloride, what we're going to do is we're going to figure out the number of moles of barium sulfate, or excuse me, barium chloride, and that will tell us the number of moles of barium sulfate. So they gave us the volume of our barium chloride and its molarity, and so from that, what we're going to do is we're going to multiply those two. We're going to say 0.164 liters times 2.96 moles per liter, and that will give us the number of moles of barium chloride, which is 0.485 moles of barium chloride. And from our two balanced equations, we can see that that is also equal to the number of moles of barium sulfate. So let's write it here. I'll just write it the whole number. 0.485 moles of barium sulfate, like that. There we go. So the barium sulfate that was produced came from both zinc sulfate and sodium sulfate, each of which was produced in a 1 to 1 ratio. And therefore we can write out a new equation, and we can say, well, that 0.485 moles of barium sulfate came from the sum of the number of moles of zinc sulfate and the number of moles of sodium sulfate. But since the equation asks for the mass of sodium metal in the mixture, what we have to do is relate the mole amounts of zinc sulfate and sodium sulfate to zinc metal and sodium metal. And you see that the ratio of zinc and zinc sulfate is 1 to 1, whereas sodium to the sodium sulfate is 2 to 1. And so based on that, we can write out a new equation, and we can say 0.485 moles of barium sulfate is going to be equal to the number of moles of zinc, but then we're going to have 1/2 the number of moles of sodium because it's Na2SO4. So there we go. So now what we're going to do is we're going to take this equation and we're going to express it in terms of mass, since they gave us the mass of a mixture. So if you're wondering, well, how am I going to do that? Well, let's see here. We know the molar mass of zinc, and we can say that 1 mole of zinc over its mass of 1 mole, so its molar mass, so 65.38 grams of zinc. So what we can do is we can multiply that by the mass of our zinc. We'll just call that X, okay? Because mass times mass would give us number of moles, okay? So we're going to tally that up with 1 mole of sodium over, of course, 2 times the molar mass of sodium, which is 22.99 grams of sodium, like that. And we'll multiply that by Y, and Y would be the mass of sodium. So we have X is the mass of zinc, Y is the mass of sodium. Again, if you multiply mass and mass, you end up with number of moles. So essentially you're using mass to figure out the number of moles, and when you tally that up, of course it should equal 0.485 moles, like that. So that equation has two variables in it, doesn't it? It has X and it has Y. It has the mass of our zinc and the mass of our sodium. So we're going to need a second equation that relates the mass of sodium and the mass of zinc. So I'm going to put mass of zinc plus mass of sodium is equal to the total mass of the mixture, which is 25.40 grams. And I'm going to solve that for X. So X, which is my mass of zinc, is going to be equal to 25.40 grams minus Y, like that. So now I'm going to take this 25.40 grams minus Y, which represents X, and I'm going to plug it into the equation here so that I end up with only one variable. So I only end up with Y. Now I'm going to simplify it a little bit by leaving out grams and moles because we're just going to solve this thing for Y. So we're going to say 25.40 minus Y over 65.38 plus, what was it here? Y over, 45.98. And of course, all of that is equal to 0.485. Again, I'm going to leave out all the units here and just solve for Y. So we end up with 0.3885. Subtract 0.0153y is what I got, plus 0.0217y is equal to 0.485. Like that. I'm going to simplify it a little more. I put 0.00645y. I think I added an extra sig fig there, is equal to 0.0935. Doesn't matter. I divide both sides by 0.0645. So let me just clean this number up here. This is supposed to be a 0 here. That didn't come out so well. There we go. And I solve for Y, and I get the Y, which is the mass of my sodium, is equal to 14.50 grams of sodium. So if I want the mass percent of sodium, I'm going to say mass percent of sodium is equal to the mass of sodium divided by the total mass of the mixture, which is 25.40 grams. I multiply all that by 100%. Now, technically, I should only have 3 sig figs because they gave me 3 sig figs in my volume and my molarity. So I'm going to report this to 3 sig figs, and I will say that it is 57.1% sodium by mass. So I hope this helps you out on homework 4, question 25.